Hello, and today we'll be talking all about acids and bases and the reaction of them, which is also called a neutralization reaction. And we will get into why it's called such a reaction later on. Alright, so first let's define what this reaction is, right? I just said it, that it's an acid and base, and then it gives us something. Well, first let's look at each one of these. Well, what is an acid? An acid is anything that has a pH that is less than 7, right? And it has hydrogen. Now, a base, on the other hand, has a pH greater than 7, and it has hydroxide, which is 1-, and a hydrogen is 1+. Right? So these are our basic definitions of acids and bases, and basically both acids and bases, they break down things. For example, base is like a detergent, right? They break down oils, they break down fat. Acids are like lemons, right? So acids are rather sour and bases are bitter. You can remember it like that. All right, so there is a generalized form to look at when talking about acid and bases reaction, but first we will do some equations ourselves and we will come to that generalized form ourselves, because I think that helps and that you will actually understand what is happening in the reaction rather than just remembering written down generalized form, because that can be forgotten. But if you know how to go from scratch, then you can always be sure that you will get the right answer. Alright, so let's look at a reaction where you have the hydrochloric acid, HCl, plus a magnesium, just plus a metal, right? So what might that be? And I encourage you to think a little, like what could possibly happen here. Alright, so I hope you've done this yourself and you're just coming back right now. So the answer to this will be MgCl2 plus H2, and to balance it you just have to add a 2 over here. So what do we have over here? Well, look, this is a salt, a chemical salt. So what is a chemical salt? A chemical salt is basically anything that has an ionic bond. That's a metal that bonds with a non-metal. So here our metal is magnesium, right over here, and our non-metal is the chloride. And what do we have left? Well, we have a hydrogen left. So we're left with H2 because it's a diatomic molecule. All right, so this was our first example. Let's move on to our second example, where we're going to have nitric acid with magnesium oxide this time. There's an O at the end of it. All right. Let's look at what could possibly happen here. And once again, do this yourself, balance it yourself, and then come back if you have it right to check the answer so you think as well. Alright, so we know that the NO3 will pair together with magnesium. And NO3 by itself has a charge of 1-, right? And magnesium has a charge of 2+. So what you need to do to get them to their balanced form is you have 1 magnesium and then NO3 bracket 2, right? So you have, in the end, you have 2 minuses that cancel out the 2 pluses of the magnesium. You can think about it like that. And then what do you have left? Well, I have hydrogen and I have oxygen. Well, that's obviously going to make H2O. That makes water, right? So here's our salt over here, and here we have water now. We don't have just hydrogen, we have water. And to balance this, we're uneven in our hydrogens, and we can just put a 2 over here, and now it's balanced. All right, so let's move on to our next example, where you have hydrochloric acid once again, plus sodium hydroxide, OH. So what could this possibly give us? What would our salt be? Well, our salt would be NaCl plus, what do we have left here? Well, we have hydrogen, 2 of them, and a water. We have a water. Once again, we have a salt, and we have our water. All right, and this one doesn't need balancing. Let's look at our final example where you have sulfuric acid plus zinc carbonate. So what could this possibly be? Well, let's find our salt. What would our salt be? Well, it would be zinc sulfate. And what is the charge of sulfate? Well, sulfate, this right here, that has a charge of 2-. And zinc has a charge of also 2-. So they go together just like the way they are. Then we have what is left? Well, we have a hydrogen and an oxygen. We have a H2O. But what's left now? Oh, we have a carbon, and we have carbon dioxide left. And to balance this, there is no need to balance it because everything's already balanced. And this is our outcome. We have our salt, we have our water, and we have our carbon dioxide. This is our outcome over here. So now let's look and try to generalize these formulas. So our first example, what do we have here? Well, we have an acid and a metal. And what that gave us was a salt and hydrogen. Right? Makes sense. And then over here, we had an acid and a metal oxide. And that gave us a salt plus water now. That makes sense because we have an oxide, so that oxygen bonds together with the hydrogen to make water. Here we had an acid and a metal hydroxide. Now this gave the same as last time. It gave us a salt and it gives us water because we're not adding anything new. Hydroxide is hydrogen and oxygen, and there's no new chemical, no new molecule added, so there's not going to be a new substance added. Okay, what do we have here? Well, here we have an acid and a carbonate. Now, what might this carbon do? Well, this carbon just created CO2, as we just saw. So we have a salt, and we have water, but here we also have carbon dioxide. So, if you look, these are our 4 generalized acid reactions. Acid and metal, which gives you salt and hydrogen. Acid and metal oxide, which gives us salt and water. Acid and metal hydroxide, which gives us also salt and water. And acid and carbonate, which gives us salt, water, and carbon dioxide. Now these were almost all of the acid reactions possible with metal, and I challenge you to spot the one that actually involves neutralization. Have a little think and then come back. Well, to answer this, we must think, what makes something neutral, right? What is a neutral substance? Well, a neutral substance is the pH of exactly 7. And just so we know what this substance is, H2O, so water, has the pH of 7. So, a neutralization reaction is any reaction that turns an acid to have water. So this is neutralization because we have water. This is also neutralization because we have water. And this is also neutralization because we also get water. The acid gets neutralized. Here we don't have water, but what we have is hydrogen. And nowhere can we find a substance that would be acidic. A salt is not acidic, and neither is hydrogen. So this is also a neutralization reaction. So all of the ones we've talked about have been, once again, neutralization reactions, because this is the video. This is the theme of the video. And the reason why they're called neutralization reactions is because they all produce a neutral substance in the end. You mix an acid with something else, with something that acts like a base, and you get a neutral reaction which often results in water. And that is how the name came to be. Alright, so I hope this video was helpful for learning acids and reaction, and you have now understood the principles of it. And just to make sure, these are all of the 4 types of acid and basis reactions that we have. There is one more, which involves ammonium, but this video doesn't talk about it. So these are the 4 types of reactions that we looked at this video in their generalized form. However, I truly recommend thinking about the reactions and not just relying on memorizing these generalized forms, because you can forget this, but what you can't forget is the logic that goes behind them. So if you understand how these are derived, then you can always come back to them and figure them out yourselves. Alright, thank you for watching, and see you next time.